All right, sorry. All right, so we're going to graph these inequalities. Has a y-intercept at -4 and a slope of -1. So down one, right one, down one, right one, or go up one and left one in the other direction. All right, so those are the points that live on this line. We only want the y values that are greater than the points on this line. So that means we can't be a point on that line and be a solution. So do I want a solid or dashed line? Dash, dotted, whatever you want to call it. All right, so that makes a boundary between x and y values here and x and y values on this side. We have to shade where the answers are. The answers are going to be where y is greater than the points on this line. So guys, you got y values living on the y-axis above your line on this side. You got y values living on the y-axis below your line getting smaller on this side. If you want y to be greater, should we shade where y is above it or below it? Above. So any ordered pair that landed above this line will make this inequality true. But that's not what we want. We need x and y values that make all of these inequalities true. So let's graph the next one. All right, so now we have to graph where y is less than or equal to 0. So first we're going to graph the line y equals 0, and he'll be our boundary. Guys, where does y equal 0? Right smack in the middle. So here's where y equals 0. This line has every y-coordinate equaling 0. So draw yourself a few more points that also have a y-coordinate of 0. Guys, I'm going to try and trick you. Does this point right here have a y-coordinate of 0? No, it's got a y-coordinate of 1. He's got a y-coordinate of 2. He's got a y-coordinate of -1. So I can't move up and down because y will change. So if I go to the right or if I go to the left, do all of these have a y-coordinate of 0? Yeah, so it's a horizontal line. So you're basically tracing the x-axis. The x-axis is the line y equals 0. Every x-coordinate has a y-coordinate of 0 on the x-axis. Solid or dashed if we want y to be less than or equal to 0. Solid, because it can equal 0. And now we have to shade. If they want y to be less, do I want to shade above or below 0? Above this line. Below, where y is less. So now, right now, if those were the only two inequalities in our system, this piece of pie would be our solution set. Above the black line, but under the green line. This little strip of pie. But we have a third inequality we have to add into the mix. So now we have to graph where x is less than or equal to 0. So first graph the line, x equals 0. So guys, where is x 0? Right smack in the middle again, so we share that point. And now plot a few more points that also have an x-coordinate of 0. Well, I can't go here and I can't go here because that would be x is 1 and x is -1. So I can't go right or left or else x changes. But I can go up and I can go down, so it's what kind of line? Vertical, thank you, whoever whispered that. And now we have equal to, so we want a solid line. So you're just tracing the y-axis. The y-axis is the line x equals 0 because every point on the y-axis has an x-coordinate of 0. All right, now we got to shade. They want x to be less than 0. So when you're dealing with a vertical line, you can't think of it as shading above or below it because it's a vertical line. There is no above or below. You have to think, do I want to shade to the right or do I want to shade to the left? Guys, they want x to be less than 0. Should I shade to the left of it or the right of it then? Left. So any ordered pair that lands to the left is a solution. So now you're looking for black, green, and blue to overlap. And the only place they overlap is above the black, to the left of the blue, and under the green. This triangle right in here. That is the solution to this 3 inequality system. So it forms a triangle that has a corner here, here, and here. What's this dot right here? 0, 0 is one of your vertices of that triangle. What is this dot right here, the other corner? 0, -4. And the last one right there, -4, 0. Beautiful. What's up? Well, technically, the answer is that right here. These are the ordered pairs that will make all three of these inequalities true. This isn't the answer to the system at all. It's just a bonus question they asked you. It has nothing to do with the actual solutions to the system.
Talking about like why?
Are you okay? Are you sure? All right. All right. We have one more thing we have to do in this section, and then we are done with it, and we are done with chapter 3. So some quick notes. We're out of here. All right. The last thing they're going to ask you to do in this section is, yesterday, they gave you the system, and then you graphed the solution sets. Now, they're going to give you an already graphed system, 2 inequalities, the overlapping, all of it. What they didn't tell you is what the written system was. What were the 2 inequalities that made up this system? So you're going to have to write the inequalities now, which, guys, at the end of the day, these are linear inequalities. They're lines. So we have to write the equation of lines. We already did that. To write the equation of a line, you're either going to be y equals mx plus b, right, if you're a slanting line, and you have a slope and a y-intercept. You're either going to be a horizontal or vertical line, and then you have to have your equation where y equals a number or x equals a number. So those are the 3 options we're going to have when we start writing these systems to write these linear inequalities, these lines, if you will. Those are the formulas that we're going to use. All right. Now, my notes are a little bit nicer because mine are color-coded. Yours are obviously black and white. So if you look up here, it might make it a little bit easier, even though the glare is horrible. I'm sorry. So we have a red inequality and a blue inequality. We have to write an inequality for each of them. Let's do blue first. So this is what you got to go through. If you are looking at the blue line, do you guys agree he slants? He's a slanting line. So he's going to be in y equals mx plus b. Or he's going to have a slope. It's going to have a y-intercept. We're going to have to find all that out. So let's get started. The easiest thing to find is the y-intercept. So let's start with his b. Who's his y-intercept? What number? 3. We're going to need his slope. So let's go get his slope. So from your y-intercept, in either direction, go find me another really good point. So no, boom. He meets right at that corner. That's another good point. And now we're going to be able to count our slope, our rise over our run. Well, guys, first of all, your blue line goes up to the right. Should his slope be positive or negative? It should be positive. So make sure you get a positive number for this. So how many did you have to go up? What's your rise? Up 2 is positive 2. And then how many did you have to go to the right? Right 3 is positive. So your slope is 2/3. So guys, you have your M and your B. Now it's the details. Now you got to figure out what kind of symbol are we going to put in this inequality. Well, one detail is, guys, it's a solid line. The solid line tells you that you have to have that equal to part of the symbol. It's got to be a less than or equal to or a greater than or equal to symbol. All right, and then we're going to figure out where they shaded. If they shaded above your line, that's a greater than symbol. If they shaded below your line, that's a less than symbol. So guys, try to picture the blue. The blue has this side. Did they shade on this side of the blue line? No, there's no shading on this side of the blue line, which means they shaded on this side. So this is the side of the blue line they shaded on. And now look at your line. On this side, is the y-axis below your line or above your line? Below, so that means they must have had a less than symbol. All right, so let's put it all together. So we're going to write an inequality. Y is, we said they shaded below, so y must have been less than the line. It's a solid line, so it had to have that equal to symbol. And now give me your mx plus b. M is 2/3 x, and then plus b. And there's that inequality. All right, go ahead, what's up? You got it?
No. How do you tell where it lands on without it?
It is. This one, and I'll tell you right now, Darian, I was going to say, you didn't say anything. When we go to do the red line, I will apologize. It's probably not the best example. However, I have no control over it. It is, if you ask me, the red dotted line, it's hard to see where the next good point is. It's really, really tough. I do not think any of the other ones that I've assigned to you are as tough to see as this one. But I agree, Darian, it's not easy to see where the next good point is. So let me just kind of walk you through it and we'll decide together. All right, if we do the red line, first things first, guys, look how he's slanting. Should his slope be positive or negative? So keep that in mind. All right, first let's start with his y-intercept. Where did he cross the y-axis? At -1. Now from there, either going this way or this way, try to find the next good point. So here's the thing. When I first did this problem, do you agree it almost looks like that right there's the next good point? Which would be a slope of 1, down, or -1, down 1, right 1. If you go down 1 and right 1 again, does it hit perfectly again?
No.
So that's how you know it couldn't possibly be 1. Otherwise, that slope would have continued. So I'll give you a hint. This one was not exact. This one's definitely not. This one's definitely not. This one's kind of like, oh, it looks like he just missed it. They're like just under that corner. And then this one right here. That's the next best point. And I apologize. I know that one's hard to see. I think the other ones that you've been assigned are going to be much easier to tell than that one. So let's see where your slope is. Rise over run. You had to rise down how many? Down 4, which is -4. And then to the right 5 would be +5. So your slope is -4/5. And I agree. That is not a really great one to look at. All right, now let's get the details. It's a dashed line, which means, does he have an equal to in his symbol? No. And then what was his symbol going to be? Guys, there's this side of the red line, and then there's this side of the red line. Did they shade on this side? No, they shaded on this side. So on this side, was the y-axis above the red line or below it? Above would be greater. So since they shaded above, we know y must have had a greater than symbol. All right, let's put it together. So y, they said they shaded above, so y must have been greater. It was a dashed line, so no equal to in that symbol. And then give me your mx plus b. -4/5 x minus 1. And you're done. Okay? Yes? Yeah, because you went down 4, which is negative, and you went right 5. Right? And again, that's a negative sloping line, so you better end up with a negative slope. Okay? All right, let's try number 2. So again, I think mine makes a little bit of a nicer picture because, like I said, mine's color-coded, and yours is in black and white. All right, guys, do both of these lines slant? Yeah. So they're both going to be y equals mx plus b. There should be slopes. There should be y-intercept. Let's do it. All right, here we go. Let's do red first. Red is got a y-intercept at 2. Let's get his slope. Should his slope be positive or negative? Positive. Look at how he's slanting, right? So from 2, either go this way, there's not a lot of room, or go this way to get to your next best point. It's like definitely not. Boom, right smack in the corner. Definitely not. Boom, right smack in the corner. So count from one dot to the next. If I go from here to here, what's my rise? Up 2 would be positive. And then how many to the right? 1 is positive. So that's 2 over 1. That's a 2. You don't have to put 2 over 1. All right, now the details. It's a solid line, clearly. Which means, does it have an equal to in his symbol? Yep. And then let's see where they shaded. Did they shade above this line or below? Guys, here's the red, right? You got this side of the red line where if you come down here, did they shade on this side of the red line? No, they didn't. Look at that blank. They shaded on this side of the red line. So on this side of the red line, was y above or below? Below. So that's a less than symbol. All right, so we would have what? Y. We said it has to be a less than symbol. It's solid, so give me that equals 2. And now give me your mx plus b. 2x plus 2. All right, I want you guys to do blue. You do the blue. Get your y-intercept, get your slope. Make sure it's the right sign, because look how that line slants. And then see how they shade it. I'm looking at the blue one, right? Now look how he slanted. Should his slope be positive or negative? Positive, right? I'm going to write the information down here. Clearly it's dashed. We can all see that. Right? As long as it is slanting, it's going to have a slope, it's going to have a y-intercept, and you should be writing an mx plus b. I saw some good answers already. What was the blue line's y-intercept? -2, right there. The slope, well, -2, guys, if I go this way, it's like, oh, boom, 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 boom. What was the slope? 1/1, right? It went up 1 and right 1, so the slope is 1. It's dashed. Now let's figure out if they shaded above or below. Guys, there's this side of the blue line, and there's this side. Did they shade on this side? No, look at that. That's empty. That's shaded on this side. So on this side was y above or below? Above. So that would be greater. So you want to make sure you're saying y is greater than the line. All right, here we go. So y is greater, no symbol, no equal to, it's dashed, and then you would have 1x minus 2, and you're done. All right, couple more. Let's look at some horizontals and verticals now. All right. These ones have been confusing some students in the sense that what they did is they only showed the answer shaded where it's overlapped. They cut off all the extra shading. So guys, for example, they clearly shaded on this side of the blue line. Well, they're both blue, of the slanted line. But it only overlapped here. So they chopped all of this extra shading off and only kept the overlap. So here, they shaded to the right of this line, but they cut off the excess where it didn't overlap. So they only left the solution, the shaded overlapping region. So that was confusing some students, like, wait, where's all the shading? It's no big deal. All right, do you guys agree? We have a slanting line, so he's going to be an mx plus b. And we have a vertical line, so he's only going to be an x equals or a y equals, depending on which one it ends up being. All right, here we go. Slanted line first. Slanted line clearly has a y-intercept where? At b, at 0. And now let's get his slope. Let's count it. No, yes, no, yes, no, yes. So pick 2 points and let's count our slope. Rise over run. I had to go up how many? Which is positive, and right? Perfect. So 2/1, that's 2. What's up? No, I don't think so. I think 2 they give you. Well, everybody's had 2 straight lines so far.
No, I'm talking about like the 2 actually vertical ones.
Oh, this is just the y-axis. This doesn't count.
Oh.
This is your y. They're only they put them in color, but it's all gray on yours, so I understand what you mean. No, this was just your y-axis in black and your x-axis in black, and then just the 2 blues are your. But it's it's black and white on yours. I get it. Sorry, Darian. You're all right. All right. So he is dashed. So there's going to be no equal to, and then let's see where they shaded. Guys, did they shade on this side of your line? Yeah? Is y above or below? Above. Above b's greater. Are you laughing at yourself, Darian? All right. Okay, so y, we said greater. It's dashed, so no equal to. We got a slope of 2. times x and then plus a y-intercept of 0. But guys, do we normally see plus 0 as our y-intercept? No, so you should probably just leave it as that. I wouldn't mark you wrong, but like Delta Math or anything like that, they're not looking for a plus 0. The plus 0 is assumed to be there. All right, now let's do our vertical. Okay, I think you should do this. Other students are like, what the hell is she doing that for? I think it helps. If you don't know how to write the equation of a vertical line right now, then you got to start looking at the points that are on it, and you need to establish which coordinate never changed. Somebody tell me right now what ordered pair is that? X is and Y is 0. What's that point? X is -2 and Y is 1. What's that one? -2, 2. What's that one? Guys, who didn't change? The x. And what is that x coordinate that never changed? -2. So guys, that is the line where x is always -2. So it is the line x equals -2. So we're going to take that and we're going to turn it into an inequality. We got to figure out what symbol to replace the equal sign with. So let's look at the clues. You don't got to worry about a slope. You don't got to worry about a y-intercept. That's literally going to be your inequality. We just got to take the equal sign out. Well, guys, it's a solid line. So that means, will there be an equal to part of your symbol? Yeah? Now, when you're looking at a vertical line, that's an x value. So you can't think of it as above or below, because you can't be above or below a vertical line. It's straight up and down. You got to think of it in terms of, did they go to the right or did they go to the left? So guys, did they shade to the right of this line or the left of that line? To the right. Are numbers getting bigger than -2 to his right or smaller? Bigger. So to the right is bigger, it's greater. They went right, which is where numbers are getting greater. All right, so take it, x. We said they went to the right, so take the equal sign out and put a greater than symbol in. It's solid, so put an equal to. And then what number is it going to be greater than or equal to? -2. And you're done. All right, I want you guys to try the last example. However, your shading is awful. So let me show you what it's supposed to look like. Go ahead. Is that you, Jake? Question?
Did I spell that?
Yep, go ahead. Do you need a pass?
Yeah.
Fill one out and I'll sign it. All right, so guys, again, in this last example, they only shaded, or I'm sorry, they only left the overlapping shaded part. So they cut off this excess over here that was above this line, and they cut off this excess over here that was to the right of this line here. All right? So you guys try and write me that system. There's a slanted line, and there's a horizontal line. So somebody's going to be an mx plus b'er, and somebody won't.
I can't tell.
Thank you.
Yep, where we at?
I can't tell.
Which one? The slanted line? The slanted, it's very, it's negative. It's very steep, but it's going left. Perfect. Perfect. Now we do this one, right? You have this one. You can shade on this side of it or this side of it. Did they shade? So they have to be not less than -2, but.
So I have a question. How would you tell if this is like this? This would be like positive or
Greater or less than you mean?
Yeah.
Okay, so look at your line. Your line is all the way like this. So you have the y-axis getting bigger and bigger and bigger on this side of your line. Is that the side they shaded on? Yeah. And then you have y getting smaller and smaller and smaller on this side of your line. Is that the side they shaded on? No, they shaded where y was getting bigger. Yeah. Yeah. Yes, because I think you just miscounted this one. So you went from here, right, to there. How many down? 1, 2, 3, 4. Hold on. Slope is rise over run. So how many did you have to rise? And then It is negative, but you had to rise by going down 5, and you had to run 1, so upside down. Oh, yeah, it's always up or down movement first. Rise over run. And then your symbol. You have your line, right? Y is getting bigger and bigger and bigger and bigger on this side of your line, that's how they shade it on. Or you have Y is getting smaller and smaller and smaller on this side of your line. They shade on this side? No, they shaded on this side where Y was bigger. Okay, so if you look at this line, right? So you have your line here, and it's y equals -2. You have y values getting bigger and bigger and bigger than your line on this side, if that's where they shaded. And then you have y values getting smaller and smaller on this side of your line. Did they shade on this side? No, they shaded on this side where y was big. And then same thing here. You have this line, extend it a little bit. You have y getting bigger and bigger and bigger on this side of your line. And then you have y getting smaller and smaller and smaller on that side of your line. Okay. You put your inequality symbol, that's an equal sign. So when they shade on this side above it or this side below it. Above, so it'd be a greater. The same thing here. This line looks like this one is all bigger. You have y values getting bigger and bigger and bigger on this side of your line. And then you have y values getting smaller and smaller and smaller on this side of the line. Did they shade on this side? No, they shaded on this side. That's in this way. All right, guys, let me go over this. I see a lot of really, really good answers. Okay, if we do the slanted line first, slanting line, he's going to be in mx plus b form. He had a y-intercept at 3. If I look at the next good point, it's right there, which means I had to drop down 5. My rise is -5. I had to go to the right 1. My run is 1, so my slope is -5. It's clearly a solid line, and I get it. The shading, it can be a little hard to tell. This line, if you extend it a little bit to make it longer, you have y values getting bigger and bigger and bigger than your line on this side. Did they shade on this side? Yes, and you have y values getting smaller and smaller and smaller than this line on this side. Did they shade on this side? No, they shaded where y was getting bigger, so greater. They shaded above, so you need a greater than symbol. So now we have y is greater. We have an equal to for the solid line, and then we have -5x plus 3, our slope and y-intercept. Done. All right, now you have a horizontal line. If you don't know which one this is, x equals or y equals, then I keep trying to advise you to label some points on it and see who's not changing. What's that point right there? X is, and y is -2. This is, x is -2, and y is -2. You can already see who's not changing. This is the point, x is -3, y is -2. Y never changes. It's always -2. So that is the line, y equals -2. All you gotta do is change this to an inequality symbol. So let's figure out what it is. It's a dashed line, so no equal to. And now where did they shade? Well, you got this side of the line where it's above, where y is getting bigger. Did they shade on this side? Yeah, they did. And then you have this side where y is getting smaller than your line, but that's not where they shaded. They shaded where the y-axis was above your line. So that's a greater and above situation. So now we would say y is, we shaded above, so greater, it's dashed, no line, and then it's greater than -2. All right, everybody feel okay? I saw a lot of really good answers on that. All right, that's about that.